Hi everyone, my name is Charu Rawat and I'm here with my research team.
Arnab Sarkar.
Sameer Singh.
And we're graduate students of data science at the University of Virginia, and we're here to talk about an important research project that we did in collaboration with the Trust and Safety team at the Wikimedia Foundation. Before I begin with what our research is about, I'd like to thank Patrick Early and Claudia Lowe, as well as Lane Raspberry from the Wikimedia Foundation, and our research advisor, Dr. Rafael Alvarado from the Data Science Institute at the University of Virginia. So trust and safety has become quite the topic of interest in the last few years. Sir Tim Berners-Lee, the founder of the World Wide Web, at an event commemorating the anniversary of the web, talked about how online harassment is one of the biggest issues that's plaguing the internet community nowadays. And that shouldn't really come as a surprise, considering the fact that 1 in 3 Americans suffered online harassment in 2018. And that's a fact from the Anti-Defamation League survey that happened back last year. And only about 80% of Americans say that tech companies should do more to prevent it. And that's quite a big number. Wikimedia also, to that end, has their own trust and safety team. And that's really where the collaboration between UVA and Wikimedia Foundation has come to work towards solving this problem. And that kind of brings us to think about the fact that how can we, as budding data scientists, as students, do what we do best, utilize our skills, and make these communities safer from online abuse and online harassment. So Wikimedia has been, as a foundation, has been growing immensely over the last few years, and the English Wikipedia platform, as you can see from the visual behind me, has been expanding immensely. It has users all over the world, and its popularity has just been soaring. But online harassment has been a really big issue in the community. So based on a Pew Research Center survey that happened a few months ago, about half of the survey responders who took the survey experienced a decrease in their contribution and engagement levels. And a lot of them even ended up leaving the community. Now that definitely is a big cause of concern for the Wikimedia Foundation. The problem at hand currently with the way the foundation or even the platform as such combats harassment is that it's currently a human-driven process. So you have admins and moderators who evaluate each case and decide whether a user should be blocked or not. And the problem with such a human-driven process is that there's failure to identify bad behavior. There can be bias to overlook behavior in certain cases and not. And overall, there can be a massive inability to understand the complete scope and context of such a problem. So there definitely is a need for there to be a more robust process to combat harassment, something that can scale well with how big the community has been growing over the last few years and will continue to do so. Our goal to that end was to come up with a machine learning model that can actually detect abuse and predict users who are likely to sort of cause any sort of problem in the community. To that end, we leveraged a variety of data to analyze the prevalence and nature of online abuse and harassment at scale in the community. So for one of the biggest challenges in our research project was just the lack of unified data to combat this problem. So to that end, we had to build a very exhaustive and comprehensive data pipeline and go through a variety of data sets to sort of really come up with a very comprehensive data repository through which we could, work and perform analysis. So we went to about a total of 5 data sets for all our work. A couple of them that are listed in my visual are, say, the user blocks data that basically helps you identify a list of blocked users in Wikipedia since its inception. And we were able to access that data through SQL queries or structured query languages through the Wikipedia Toolforge database that exists. We also use the user activity stats, which essentially gives you information regarding the metadata, regarding every revision that a user has made. It's important to highlight that our research only focuses on the English Wikipedia platform and especially only on namespaces 1 and 3. The third and the most sort of important data set that we've used for our analysis is the user comment text data. This data is truly big data in its nature, and to access that data, we developed our own Python web scraper that would just crawl through all the websites and extract all these conversations that were happening between users and as well as on their pages. And we were able to sort of extract all those comments, and we leverage that later when it comes to sort of building our abuse model. The fourth data that we used was the ORS score data. Now, people who've been familiar with Wikipedia know what this is, but essentially it's wiki automated edit quality scores that are sort of allocated to each edit made by a user. We'll sort of dive a bit into the details of that later on. And the fifth data set that we used was the Google X Machina data set. That essentially was a data set that was generated from this research collaboration between Google Jigsaw and the Wikimedia Foundation in the area of combating abuse. So we used the data set to sort of validate our processes that we'll talk about later. So the first step in our entire research was to just perform some exploratory data analysis using all the data that we had. To that end, we analyzed the user blogs data as well as the user activity data to sort of understand what goes on in the blogging ecosystem of Wikipedia. So a very interesting observation that we came across during our preliminary data analysis was that if you look at the time period from like 2004 to 2018, about the end of October, November 2018, we see that a total of about 1.02 million users have been blocked in Wikipedia, in the English Wikipedia till now. Of that, about approximately 91.5% are registered users, whereas about 8.5% are anonymous users. And we see that there's a massive spike in 2017 and especially 2018 in the number of users that were getting blocked. We also sort of looked at the share of the reasons for which users have been getting blocked over the last few years. And there were a couple of interesting observations here. One being that, there isn't like one particular reason or one particular action that leads to a user getting blocked. While we do some major share in reasons such as vandalism or users indulging in spam, sock puppetry, or user violation, one of the takeaways is that harassment can take multiple forms, and that's reflected in the Wikipedia community as well through this data. An interesting observation here that sort of ties back to the spike in the user blocks in 2017 and 18 was that when we look at the share of reasons for why users are getting blocked, we see this massive increase in share for the reason proxy. Tying all insights together, we could conclude that primarily the increase in user blocks in 2018 was only in the 2 months of September, October, up to the point we had our data, and that was only, the increase in user blocks was only due to anonymous users getting blocked due to being proxies. We also sort of looked at the aggregated activity stats of users, so basically analyzing how users have been editing over time, if there are any particular characteristics of blocked versus non-blocked users as to how they edit in Wikipedia. One of the insights that we were able to sort of take away was that if you look at an 8-week rolling window of every user, we realized that for blocked users, 90% of all those blocked users are mostly active in the week immediately prior to them being blocked. And these sort of insights were really important in us sort of building our analysis on further, and something that we'll go on elaborating.
Now that we have all the different data sources, what did we want to do with it? The goal for us was to create a model which predicts the toxicity score for each user comment. And for that, we used all the different data sources which Charu just talked about. And when we started with it, we faced broadly 3 main challenges. First of them was data cleaning and pre-processing. So the data consisted of a lot of Wikipedia-specific lingos and terminologies, and then it also consisted of special characters and other texts which weren't of importance for our model. So we had to do a data cleaning. The next problem was ground truth labeling. We know a user got blocked, but we don't know which comment led to a user getting blocked. They might have done something block-worthy a day before or a week before. So getting the specific text which led to a user getting blocked was problematic for us. So we did a lot of work to do the labeling. The next problem was class imbalance. So by inherent nature of the blocked users, the percentage of blocked users were less than 1%. So to create a model which was robust in identifying them, we had to upsample them and essentially get to a ratio of around 30 to 70%. Now, when we have these challenges taken care of, how do we build the model? So we followed a really traditional approach. We started with data aggregation and annotation, and then we did feature extraction using natural language processing and orthographical features, and then we implemented the different machine learning algorithms, or different classification techniques, all the while doing test and train split and doing k-fold cross-validation to see whether we were overfitting or not. And we went a step ahead to understand the extent of overfit of our model, and we used Google's Ex Machina dataset to compare the best performing model on that data set. And then in the end, we did a bit of model tweaking to get to the set of results which were more favorable for our project. Now, deep diving a bit into how we did the feature extraction. Well, we started with natural language processing using character and word n-grams, and then doing NLTK sentiment analyzer, latent virtually allocation, and then we moved on to word embeddings using both glove and fast text. And on the orthographical feature side, we started with understanding how many numeric digits are there, how many special characters are there, and similar features. Then, given we have we're using these data sets, another important question for us was, what is the metric we want to use to compare these models? Because of the class imbalance, we didn't want to use accuracy, so we went ahead with using area under the ROC curve. And then after having decided the metric, we leveraged different algorithms, starting with logistic regression, then linear SVM, and random forest classifier, and we got the best accuracy of around 68% with XGBoost classifier. And after that, we did a bit of threshold tweaking to maximize the recall rather than precision, and we got to a best accuracy of around 71%. Now, we have this model which detects abuse, but when we look at our data, does the data share the same story? So to understand that, we did an evaluation of the toxicity score. So as you can see, on the x-axis we have toxicity score, where 1 denotes the maximum toxicity and 0 denotes no toxicity. And on the y-axis we have user comment sequences, 0 being the most recent comment. And you can see, as we move ahead from the 5th to 0th or the most recent comment, the toxicity for blocked users denoted in red increases and shifts towards right. And that sort of validates our point that the model is able to capture toxicity inside the dataset. And this lays the groundwork for us to create a predictive model to detect the propensity of blocked users.
So far, we have spoken about the abuse detection model, which generates toxicity scores for these individual user comments. Now our next goal would be to develop a user risk prediction model, which will be used to flag users who can be problematic in the future. We would be using various inputs like the ground truth labeling from the user block data. We will be using the user comment text data, the ORA scores, and even the activity scores. So, as I mentioned before, the very first inputs to our user risk model are the toxicity scores. For the recent 14 comments, user comments for each user in the latest 2-week period, we'll get the toxicity scores from the abuse detection model. For the same 14 comments in the 2-week period, we'll also get the ORA scores. And here we'll be talking about the two different ORA scoring mechanisms called the good faith and the damaging. And so we'll be having 28 of these scores for each of the 14 comments from these users. The next inputs will be from the user activity stats. These are basically meta information which are gathered for each of these users, and we have 6 of these features. We have the variance for the edit counts. We have the variance for the edit lengths. We have something called the minor count. We have the deleted edit counts. We have the number of days each user is active in that 2-week period, and we have whether a user is anonymous or not. The next inputs are the username features, and these are basically 200 character n-grams which are derived from the username of these users. Using all these features, we build our user risk model, and we try out various ML algorithms. We try out linear SVMs. We also tried out logistic regression as well as XGBoost. And as mentioned before, we used the area under the ROC curve as our measure, and we saw that the XGBoost model gave us the best AUC at around 90.3%. we've also wanted to optimize this further. We wanted to have the best recall for our models, so that the admins at Wikipedia are able to look at a larger pool of possible abusive users, and using this metric, the admins would likely have to look into a lot of false positives in the data. To get this, we tweak the classification threshold in such a way that we get the best AUC, as well as the other metrics such as recall, F1, accuracy, and we found that the threshold of 0.3 gave us the best results. So here's the final visual of how a model would look. The users who get flagged by this model will have scores of greater than 0.3, and based on their user comment data as well as the activity stats, the admins will be able to look at these users and better determine who among these may be abusive in the future.
So thank you for listening to us. We'd like to say a big thanks to everyone in the Wikimedia community, as well as again Leon Raspberry, Claudia Lowe, and Patrick Early from the foundation for helping us out and assisting us with all our research. We had an amazing time doing this project, and we hope that our research helps the trust and safety team do more towards combating harassment at the platform. Thank you for listening to us.